minutes. Oh, thank you. I'm going to go ahead and I'm going to use that code blocks. I'm trying to use that for the videos and stuff so that in future semesters, if I have any Mac users, everything will be kind of consistent. But you can use dev C++ on these machines. That's fine. I'm going to start up a new, so on yours, you can just do a new source file in dev C++. If you're using code blocks, you need to do a new project. Just loop, loop something. I might name mine loop demo console application is what I'm doing. Plus, I'm going to name this. And remember, if you're using code blocks, don't have any spaces in your names. Loop demo. Or don't, even if you're using dev, don't have any spaces in your file names. All right. So I'm going to put some comments up here at the top. Put a block of comments there. I'll just call this loop demo. Using the code blocks compiler. All right. I'm going to say this program will demonstrate how to use counter-controlled. I'll say counter, sentinel, flag, and end of file loops. And one thing I'm going to point out here is all these loops will have those three main parts of the loop that we talked about. So you guys remember that? So we're going to initialize, and then we'll test, and then we'll update, right? So, and we'll have those three parts, but they'll look different based on what type of scenario we're looking at, okay? So I just wanted to point that out. And then after you get all that, go ahead and do your basic template setup for your program. We'll probably need a couple of other include files or header files. So you need to have number include, IOStream. We'll need fstream for the end of file loop. So you want to add that number include fstream. And then we might want to use something like set width or something, or set precision. So let's include IO manip so that we can use those things if necessary. Oh, and I can get rid of this hello world. You don't need that down there. Okay. Now we need to come up with some kind of idea or task that we want to accomplish with our loops, just to kind of demonstrate how the loops are going to work. So this is a common thing to do. What if we wanted to add up and find the average of a series of numbers? Okay, that's a pretty common thing to do. And so we're going to do that. We're going to find the sum and the average of a series of numbers. But just keep in mind that this is one problem or application that we're focused on. You're not always going to have a sum and an average in all your looping programs and exercises. I say that because every once in a while I'll have a test, on one of the exams or something like that. It'll have nothing to do with finding the sum or average of numbers or whatever, but since we'd seen it in the example, somebody will have a sum running around for whatever reason. So anyway, so I'm going to declare some variables up here, just so we have some to work with. Say, put a comment here, variable declarations. And so let's declare an integer named sum. That will be used to add up all the numbers. We're going to have a variable. We can have a variable named counter. That's a good name for it. Counter is going to be used for different things depending on what type of loop it is. But if nothing else, we can use the counter to know when we go to find the average, we need to know how many numbers to divide by, for example. So, and then I'm going to have another variable. I'll just name it number. Number will be the actual number that I'm dealing with at the time. Okay. And then if we want to find the average, now we might make that a double. Make it name it average, something like that. All right, so those are just some variables that we're going to have. Okay. So let's go ahead and compile and run that just to make sure that much of it works before we start adding anything. So okay, so it compiles and runs. Doesn't do anything really at this point, but at least we know we have something working right now, right? Everybody cool with that? All right, so what I want to look at these different types of loops or different scenarios that you might use a loop. Right, so the first one is a counter-controlled loop, okay? So I'll just make a comment here. This will be a counter-controlled loop example. So use a counter-controlled loop when you know exactly how many times you want your loop to go through. And so remember I mentioned something last time, this concept of a loop control variable. Your loop control variable is going to control the loop, basically. in a counter controlled loop, your loop control variable is going to keep count of how many times you've gone through. And so on this one, we can use that counter variable, for example, to keep count. That would be a good candidate there. Right? And also, one other thing that we need to do is we need to initialize our sum to 0 because we're going to be adding to it. If you don't initialize it to 0, your compiler may or may not start it off at 0. In C++, it probably won't start off at 0. I think the dev compiler, the newer versions of the dev compiler, might automatically initialize it to 0 for you, but I don't think the older versions or code blocks will. So anyway, we'll test it out and I'll come back and add it. We'll see what happens. Okay, so I'll leave a little space there. All right, so as far as the loop setup goes, we want to initialize, right? So what would that look like here? So we need to start off our counter at something. So we can either start it off at 0 or 1. I'm going to start it off at 0. So I'm going to say counter is equal to 0. Okay? So that's what that looks like. So that's how you initialize. And then you're going to test. Well, how many times do you want this to go through? So we're going to decide, let's just decide how many numbers that we want to have, okay? So how about like 7 or something like that? And so we can use this as a while loop. While counter is less than 7. I'm going to do it like that. And then open and close curly brackets. All right, so that was your test, right? So that's the logical test part. And then what would the update look like? And the update is usually going to be at the end of your loop. So if you have a counter-controlled loop like this, it needs to keep count. And so on this one, we just need to have it count up by 1 every time. So you can just say counter plus plus. You could have said counter is equal to counter plus 1, or you can just say counter plus plus. And so that's your update, right? So we have the 3 parts. We have the initialization, we have the test, and we have the update. So that's the loop setup. Okay. So what do we want it to do inside of there? Well, if we want to do something like input, maybe we want to get 7 numbers from the keyboard and then find the sum and the average. So how would we do that? Well, we need to get the numbers, right? So I'm going to say get a number. So I'll say something like cout, enter a number. And then cin number. We're going to store it in that number variable. Okay. So that'll get a number. So every time it goes through this loop, we're going to be doing whatever we need to do with that one number. When we're going to be reusing the number variable. Okay. So the next time it goes through the loop, we're going to get another number. Whatever was in there before will be replaced by the new number. So anything we need to do with the number, we have to do it inside the loop. So really the only thing left to do is add it to the sum, right? So we can say sum is equal to sum, I assume, sum plus the number. So get a number, add it to the sum, update your counter. And then the next time through the loop, you'll get another number, add it to the sum, update your counter. And so that loop will go through 7 times, right? The values of counter will be 0, 1, 2, 3, 4, 5, 6, and then when counter becomes 7, 7 is less than 7, the test part will be false, and it will exit out of the loop. After you finish getting your sum, after the loop is finished, you should have an accurate sum. And so after that, you can calculate the average. There's no point in calculating the average inside of the loop because you don't have the finished sum yet. Calculate average. So there we'll just do average is equal to, we want to do sum divided by the counter, right? If you want an accurate, if you just do it like that, because sum and counter are both declared as integers, it'll do integer division, right? But so if you want an accurate floating point result for the average, since we declared it as a double, you need to typecast at least one of those into a double. So here's the easy way to do it. And I'm going to typecast both of them just so that it shows that I know what I'm doing, that I meant to do that. Average is equal to double sum divided by double counter, right? So that's kind of the shortcut way of typecasting. I know in the book back in chapter 2 we learned how, if you remember, it was like static cast, double, and then whatever. So that's the newer, more standard way of doing it. This is kind of like the old C style way of doing it, but I still do that. It's easier. So that's a counter controlled loop. Let's test that out and see what happens. So I'm just going to pretend like these are maybe test scores or something. So I type in 95. It reads it in, stores that in a number, and it adds it to the sum. And so this should go through 7 times. 2, 3, 4, 5, 6, 7. Oh, I didn't output my average, right? So I probably want to know what that is in the sum too. So after that, let's add a couple of output statements. Output results. Cout sum, something like this. Sum is equal to, followed by the value of sum, and indel. And cout average is equal to, followed by the value of average. Let me just test that real quick. All right. So what happened there? So all my numbers that I typed in were like 80 something or 90 something, right? But if you look at my sum and my average, obviously that's not correct, right? My sum is huge, right? So what happened? In your compiler, it may or may not have come out to be something like that. And it's because of what I was talking about a minute ago. We didn't initialize sum to anything. And so in C++, if you don't initialize your variables, it's not going to automatically initialize them for you, or unless your compiler is nice and does that. But the code blocks does not do that. So sum, it was adding the number to some garbage number that was already there. So in order to fix that, we need to go up here somewhere before our loop, and we need to start the sum at 0 so that we know it's starting off at 0. Let's say start the sum at 0. like that. So I just did that somewhere before the loop. And now it should I don't remember what my numbers were, but I can get pretty close here. My sum is 647. My average is 92.4286, right? So that sounds more reasonable. That's probably correct. Does everybody see what's going on there? I need to go down for that last part. Mm-hmm. All right. Anybody have any questions about that so far? Let's go ahead and do the sentinel code example, and then we'll stop for the quiz, okay? So I'm going to, after you get that going, I'm going to go up here and comment out all the counter-controlled loop part just so it doesn't get done. We could do these on separate files, but since I think it's easier right now just to do it on one. So I'm going to leave, I'm not going to comment out my declarations, but I'm going to go up here before I say the counter controlled loop example. I'm going to put /* and then before the return 0, I'm going to put */. So now all that's commented out and it won't get done. Okay. That way we don't have to type in all of those numbers again just for that part. Okay, so the next type of loop setup is that I wanted to show is a sentinel controlled loop. So sentinel controlled loop is an event-based loop. It's a situation where I don't know exactly how many numbers there's going to be, okay? But I want the user to keep typing in numbers, and when he's ready to quit, he's going to type in a certain specific number called, and we refer to this as the sentinel value, and that number is going to signal that we're going to end the loop, okay? So that's how this one works. So we need to pick a number for our sentinel value that's not going to be a possible regular value or realistic regular value. So maybe like a negative number. If we're assuming that they're all positive numbers, we'll do that. And so we'll just use something like -999 as a sentinel value that signals to quit. So I'm going to put a comment here. This is going to be the sentinel controlled loop example. Okay. And we're going to need our sum variable, just like we did before, to keep the sum. And we're going to need to start it off at 0, just like we did before. So make sure that you start it off at 0. And we're also, for this particular example, we're also going to need that counter variable, but we're not going to need it to keep count to control the loop. We're not going to need the counter to control the loop. We're going to need the counter to know how many numbers to divide by when we want the average. Okay? So if we weren't finding the average, we wouldn't really need the counter. But since we're going to find the average, we need the counter. And we need to start our counter off at 0. So I'll just make a note here. Needed to calculate the average. Okay, so with a sentinel control loop, what we need to do before the loop is to get the first value. Okay, and so this is going to be your initialization part. I'm going to say initialize. So we need to ask the user, something like cout, enter a number or -999 to quit. and then cn number. So with a sentinel controlled loop, you need to make sure that you tell your user what the sentinel value is, right? Otherwise, they're clueless on how to end the loop, to get out of the loop, right? So we're going to tell them, enter a number or -999 to quit. And then we're going to get the number. So that's your initialization right there. Get the first value. Sometimes we call that the priming read. We're going to get the first one. And then we're going to test it. So what would our test look like here? While. So how do we know when we want to quit? When it's -999, right? So as long as it's not -999, we want to continue. So while the number is not equal to -999, we're going to repeat. Okay? So there's your test right there. While number is not equal to -999. And then at the end, we need to do our update. For this one, our update is going to look exactly like our initialization. We're going to get the next number. In fact, we could just copy and paste that code, those 2 lines of code. Control C to copy and Control V to paste. So there's your update. Get the next value, right? If you didn't do that, if you didn't do that, then it would just go on forever, assuming that it gets in there the first time. So we still have the 3 parts. It just looks a little different, right? So once we get in there, what do we need to do? Well, this part is pretty much the same. We need to add the number to the sum. So that'll just be just like we did before. Sum is equal to sum plus the number, right? And we also need to increment that counter so that we're keeping count of how many numbers have been entered in so that we know what to divide by later to find the average. Increment counter for the average. How is it to be used in average calculation? So that's the same as before. Also counter plus plus. But again, this time counter is not controlling anything with the loop. It's just keeping count, right? The loop is controlled by number. Right? Number is our loop control variable this time. So then, after that, then we need to calculate the average and then output our results. In fact, we could just go and copy and paste that code that we had before. So these lines here, calculate the average and output results. Like that. So now we don't know how many numbers there's going to be, right? Enter a number or -999 to quit. So I'll just start typing in numbers. And it's going to keep going until I type -999, right? When I'm done, I can type in -999, and then that will be the sentinel value, so it'll exit out of the loop. So my sum is 789 and my average is 87.6667. If I run it again and just type in 2 numbers before -999, you'll only go through 2 times. Make sense? So let me know if I need to move to a different spot there. That's called a sentinel control loop. It's an event-based loop. All right. So after you get that going, finished and going, we're going to stop there, and we're going to do the quiz. Okay. And then we'll finish this next time. Next time, we'll add to this, and we will add a flag controlled loop and an end of file loop.